Before starting this Ohm's law, let's understand, revise what we have studied before. Before this, we have studied about potential, we have studied about current. Now, potential is what is actually potential? Potential is the amount of work done in bringing a unit positive charge from infinity to a point outside the field to a point inside the field. Okay, that means it is the amount of work done in bringing a unit positive charge from a point outside the field to a point inside the field. Now, what is the field? Suppose you have a charge here Q, and if you take any other charge, 1 coulomb positive charge, 1 coulomb positive charge. This is called test charge. Test charge means it is used for testing, so it's called as test charge. So if 1 coulomb positive charge is taken and it is kept near to this charged object, if it is positive charge, then positive and positive will repel and the force will be in outward direction, right? But if it is negative charge, then the force will be inward direction, that is attractive. So if Q is there, any charge is there, either it is positive or negative, there, and if you keep another test charge close to it, test charge means 1 coulomb positive charge, and if you keep this test charge close to this charge, then there will be either a force of attraction or a force of repulsion. If this is positive, then this plus and plus will repel. If this is negative, then it will attract this charge. So either there will be a attractive charge or there will be a repulsive, either there will be an attractive force or there will be a repulsive force. So there is always a force whenever there is a charge and there is a test charge. Okay, now if the force, suppose here now is F, in between these two charges is F, this is Q charge and this is, it may be positive, it may be negative. If it is positive, then it is repulsive force. If it is negative, then there's attractive force on this charge. So if this charge is taken from this point, if this charge is there and there is a force of attraction or repulsion, whatever it is, if there is a force here in between these two, now if I take it away, what will happen? That the force will decrease. If I take it from here to here, it will, force will decrease. Further away, force will further decrease. Further away, force will further decrease. But if I take it at a point which is here and there is no force of attraction applicable because of this charge at this point, then this point is said to be at infinity. Okay, this point is said to be at infinity, and the amount of work done in bringing a unit positive charge, this means 1 coulomb positive charge, from this point that is outside the field to this point P inside the field. P is inside the field and this point Q is outside the field. So the amount of work done in bringing from this point to this point, the amount of work done is W. The amount of work done is W. So W is called as the potential of point P. Okay, W is called as the potential of point P, or V of potential of the point P is equal to W. That is the work done in bringing a unit positive charge. Unit, now here it is 1, unit charge is 1. So here we define that V is equal to W, that is the work done upon charge Q. So potential is called as work done upon charge. This is the formula of potential V. Is it okay? Second thing is I. We have studied about current. What is current? The current is, suppose there's a wire and current is flowing through it. I current is flowing through this wire, right? If I connect this positively charged object, there's a positively charged object. If I connect this positively charged object having charge Q to another object which is not charged or less charged, then what will happen? The current will flow. And suppose how much current flows here? From this to this, some current Q current flows from one object A to another object B. If I connect them, this is uncharged, this will be, now after when you connect them, what will happen? B will also be charged. So what charge has flown? Suppose Q charge has flown. So the work, so here, and time taken is say T. So I is equal to, current is equal to charge flown Q upon time T. Clear? So current is equal to what? Charge flown upon time taken. I is equal to Q by T. This you have studied. I is equal to current flown from one object to another object, that is equal to this much. Then also you have studied that the charges are because of this Q charges because of number of electrons, any. Q is equal to any charge is there, whichever in this universe the charge is made. All these charges, they are made because of electrons transfer, because of the transfer of the electrons. So when electrons are transferred from one object to another object, so there's always a transfer of electrons. So due to the transfer of electrons, what happens? The object gets charged. So charging is done because of the transfer of the electrons. Got it? Charging is done because of the transfer of the electrons. So if electrons are transferred, only then the charges are developed. So if there's object A and there's object B, if electrons are transferred from A to B, then what will happen? A will get positive charge and B will get negative charge. But if electrons are transferred from B to A, then B will get positive charge and A will get negative charge. Okay. So here the current I is equal to what? Q by T. Q means charge flown and T is the time taken. I is equal to Q by T. Q is measured in coulomb and time in seconds. So I is equal, that is its unit is coulomb per second or coulomb per second or ampere, or it's called as ampere. Okay, its unit is coulomb per second or ampere, coulomb per second or ampere. So I is equal to Q by T, that is unit is coulomb per second or ampere, right? And V, its unit is volts, right? So here its symbol is what? V, and here the symbol is A. These two things you have studied. Now if there is an electrical circuit means some kind of resistance wire, and here if you connect a voltmeter is always connected in parallel to the circuit, to the resistance. The voltmeter is connected like this way. Voltmeter records potential difference, ammeter records current, and ammeter is always connected in series. So here it is like this way, and there's a battery right over here. Now what happens if you connect it like this way? So what happens that this is positively charged and this is negatively charged, right? This is positively charged and this is negatively charged. Now when you connect it, there's a switch, suppose here, and then switch is there and all the current is flowing from here to here. So when the current is flowing here, अरे जरा शांत रहो भाई, सेंटर कह दो जरा, आवाज नहीं करे भाई थोड़ी देर. धीमे धीमे बोलो, तेज तेज आवाज ना होए, यहाँ तक आवाज आ रही सबकी. धीमे धीमे अपने बोलो, अपना नीचे आवाज रहे, ऊपर ना गूंजे. So here you see, if there's an electrical circuit and the current is flowing, suppose from this direction, the current is flowing towards this direction. This is the circuit in which the current is flowing, right? The current is flowing in this circuit. So this is the circuit this is the circuit in which we have voltmeter, we have ammeter, and when the current is, this is positively charged, this is negatively charged. So when the current is flowing here, so current always flows from positive terminal to the negative terminal, right? This is resistance wire R. Now what is resistance? If you make a circuit like this way, any wire is there and current flows through it, the wire, then what happens? That offers resistance. So resistance is R, ammeter is having A, current is there, ammeter records the current, and V is the potentiometer that records the potential difference. So if you have a system of this way, this is called an electrical circuit. An electrical circuit comprises of wires, resistance, ammeter and voltmeter. Wire, resistance wire, ammeter, voltmeter. This is called battery. Battery has two terminals. Bigger one is positive one, smaller one is negative one. This is positive terminal, this is negative terminal. So when the current is flowing from here, it is flowing in this direction and then it passes through the resistance and then it comes back to this. And this potential meter records the potential difference. This records the current. So here V is there and I is there. So what happens that it was found that when uh, in an electrical circuit, if there is a rheostat means variable resistance, one which is showing variable resistance. This is a symbol for variable resistance. So this is a rheostat. So if there is a rheostat in the battery in this electrical circuit, rheostat can change the value of V and I. So if V changes, I also changes. This changes, this also changes. Here the reading changes, here the reading also changes. So V changes, I also changes. V changes, I also changes. So if there is a change in V, there is a change in Y, I. If there is a change in V, there is a change in I, right? So if V changes, I changes. So this is recorded. This is recorded, right? So if an electrical circuit I changes, V also changes. So if V and I, their changes are recorded, and you see, suppose the voltage is 0.5 volts, 1 volt, 1.5 volt. These are recordings, readings, and this is 2.5 volts. So like this way, these are the readings, and so the current also changes. This is say zero point 0.1 ampere, zero point 0.2 ampere here, zero point 0.3 ampere, zero point 0.4 ampere, zero point 0.5 ampere. Suppose this kind of readings are there. So they will be uniformly increasing. This will also be uniformly increasing. And if a graph is plotted for this, if the graph is plotted for this, then you will always get a straight line. Then you will always get a straight line. This type of, if you record here V, you keep it here, and I, you keep it here on the axis, x-axis and y-axis, then you will always get a straight line. So this clearly shows that in an electrical circuit, if the value of V changes, then the value of I also changes. So what conclusion we get? That V is directly proportional to I. The potential across a circuit is directly proportional to the current flowing through the circuit. That means if the current increases, the potential also increases. This means if the current increases, the potential also increases, right? Current increases, that potential increases. Potential depends on current. So if current increases, potential increases. Current decreases, potential decreases. So V proportional to I, or simply you can say V upon I is equal to R. V upon I is equal to R. This ratio is called as V upon I is always constant, and it's called as resistance of the electrical circuit. V upon I is equal to R. V is potential, I is current, and the potential across an electrical circuit is directly proportional to current. That means V upon I is always constant. This value is always constant. This constant is called as R. And this is called as Ohms. We have studied about two things. One is potential, another is current. We already know what is potential, we already know what is the current. So if you take an electrical circuit like this way, here there is a resistance wire. This resistance wire, a potentiometer V, that is potential. uh, so this is applied here. Voltmeter, you can say simply voltmeter. So if a voltmeter is applied across resistance, if voltmeter is applied across resistance, it will be connected always in parallel. So this is resistance and this is voltmeter. Voltmeter is always connected parallel. Voltmeter records potential difference V. And here there's a battery, and this battery is connected with an ammeter. You see the positive terminal of the battery will be connected here, negative will be connected here. So like this way, this is also positive of the voltmeter, this is the negative of the voltmeter. And when the current, and this is connected to a rheostat is, it can change the value of V and I in the circuit. It changes the current in the circuit. It changes the potential or difference also in the circuit. So if you apply this to your rheostat and change the value of the different values of positions of rheostat are being taken. So rheostat is an instrument just like you regulate the speed of the fan in summer season. You can increase or decrease, so the resistance increases, so the fan becomes slower, and if resistance decreases, then fan becomes faster. The same kind of instrument is this rheostat. So rheostat, it changes the value of the current in the circuit, and then it is connected to the battery here, right over here. So the positive terminal to the positive of the ammeter, then negative here, and then negative for this here. This is the, again this is positive terminal, this is the voltmeter, this positive terminal, and this negative is connected like this way here. Here there's a rheostat, it doesn't have any positive or negative. It's connected like this way, then finally it's connected here to the battery. When the circuit, this is a key switch. So this switch is also called key here. So either you call switch or key. So this is here, and if you press the key, the current flows, and when the current flows, then the circuit is said to be closed. When the current flows in the circuit, the circuit is complete, then it is called closed circuit. Otherwise, it's called open circuit. So this is a closed circuit, and in a closed circuit, what happens here? The current is flowing here. The current is flowing. When the current flows in the closed circuit, so what happens? You change the value of, you take different readings from ammeter and voltmeter. So here you see V and I values are there. The V value, if suppose is 0.5, next value you take as 1, then next value you take as 1.5. These values, if you keep on changing the rheostat values, positions, then you will get different values of V, and you record the value of ammeter also here, and you get zero point 0.1, 0.2, 0.3, 0.4, 0.5, like this way. So here this is the table you get, and if you plot a graph for this V here on x-axis and I on y-axis, then you always get a straight line. This verifies Ohm's law, and this is called Ohm's law. Ohm's law says, write on the statement for Ohm's law: at constant temperature, at constant temperature, at constant temperature, potential across a circuit, at constant temperature, potential across a circuit, at constant temperature, potential across a circuit is directly proportional to, is directly proportional to the current flowing through the circuit, is directly proportional to the current flowing through the circuit, is directly proportional to the current flowing through the circuit. Okay, I repeat, at constant temperature, potential across the circuit is directly proportional to the current flowing through the circuit, or V proportional to I, V upon I is equal to R, where R is called as resistance, and this is called Ohm's law. Now you see, resistance is, what is resistance? Resistance, write down definition for resistance. Resistance is defined as, is the resistance is defined as the obstruction, the resistance is defined as the obstruction in the path of the flow of current. The resistance is defined as the obstruction in the path of the flow of current. Resistance is defined as the obstruction in the path of the flow of current. Okay. So resistance is just like an obstruction in the flow of the current. The current is flowing and there's some obstruction in the path of the flow of current. That's called resistance. Okay. So resistance is simply defined as the obstruction in the path of the flow of electric current. Now the current is always flows through a wire, right? And the molecules of the wire, the current is flowing through a conductor or a wire. When the current is flowing through a conductor or a wire, then the molecules present in this conductor, they offer the what? Obstruction in the path of the flow of current. They offer the obstruction in the path of the flow of current. The electron current flows because of the electrons, and the electrons are moving here through this wire. So when electrons are moving in this wire, then what happens? These molecules, they offer resistance in the path of the flow of current, and this resistance, whatever is there, that is represented by R. So resistance of a wire is directly proportional to the length of the conductor. The resistance of the conductor, resistance of wire, directly proportional to the length of the conductor. The resistance is also inversely proportional to the cross-sectional area of the conductor. If you combine both of them, are proportional to L upon A, where L stands for length of the conductor and A stands for cross-sectional area. So if you combine both of them, you get what? R is equal to rho times L by A. R is equal to rho times L by A, where rho is called as specific resistance. Where rho is called as specific resistance, and it is defined as the resistance offered by a conductor whose length is 1 meter and cross-sectional area is 1 meter square. Okay, where where write down where write down first of all, resistance of a conductor is directly proportional to the length of the conductor, inversely proportional to cross-sectional area. It's down in the denominator, so it's inversely proportional. Combining, we have R proportional to L by A. R is equal to rho times L by A, where rho is called specific resistance and is defined as and is defined as the resistance offered by a conductor and is defined as the resistance offered by a conductor whose length is 1 meter whose length is 1 meter and cross-sectional area 1 meter square, and cross-sectional area 1 meter square, where rho is specific resistance. This is called rho, ROW, rho. The symbol is called rho, right? And it is defined as and it is defined as it is called specific resistance and is defined as the resistance offered by a conductor whose length is 1 meter and cross-sectional area 1 meter square. Okay.